Example 1, create a snowman on the accompanying grid. Use the octagon given as the middle of the snowman with the following conditions. So here's what your picture looks like. We are going to calculate the width, neck, and height in units for the figure to the right. So I'm going to write down kind of like a little table. So width, neck, and height. So when we're talking about the width on this, we're talking about the distance from one side to the other. And when you count, you're counting the number of squares. So when you count all the way across, you get that your width is 20. The neck would be this top part where the middle of the snowman would attach to the head. So when we count all of our squares across, we get that our neck is 12 units. And the height would be this distance here, so how tall that body is. And when we count all of our squares here, we also get that our height is 12. All right, question B says, to create the head of the snowman, make a scale drawing of the middle of the snowman with a scale factor of 75%. Calculate the new lengths in units for the width, neck, and height. So I'm going to go back and start with my same measurements. So width, neck, and height. So on the original it was 12 or 20, 12, and 12. And they're going to use a scale factor of 75%. So this means to take each of these measurements and multiply them by 75%. Now in order to work with our percent, we need to change this to a decimal. So we move our decimal point over 2 places and we get 0.75. So our new measurement for the head would be 20 times 0.75, which is 15. 12 times 0.75, which is 9. The next question says to create the bottom of the snowman. We're going to do a scale drawing with a scale factor of 125%. Calculate our new lengths in units for the width, waist, and height. So we're going to use our same measurements from before. So width, instead of the neck, we're talking about the middle of the body, so we'll talk about the waist. Oops, and our height. So our original measurements, 20, 12, and 12. And this time we're using a scale factor, of 125%. So we're going to times this by 1.25. We get our new measurements, which will be the bottom of the snowman, to be 25, 15, and 15. So now we're talking about the head. Is it a reduction or an enlargement of the middle? So when we look at our head, our measurement started for the width started at 20 and went down to 15. So since these numbers are getting smaller, this is called a reduction. Reduction because the measurements get smaller. We can also say that our scale factor is less than 100%. When we have a scale factor that's less than 100%, as we did to find our head measurements, this means we're not taking the entire measurement of this, we're only taking part of it, so that number gets smaller. So anytime that scale factor is less than 100%, we're going to have a reduction. All right, our next question says, is the bottom a reduction or an enlargement of the middle? So if we go back to our measurements for the bottom, these measurements are getting larger, which would make this an enlargement. An enlargement because the measurements get larger. We also notice that our scale factor is greater than 100%. So when the scale factor is more than 100%, we're taking all of the original, which would be 100%, and then a little bit more. Next question, what is the significance of the scale factor as it relates to 100%? What happens when such scale factors are applied? So when our scale factor is 100%, you get the same figure. Meaning we get the exact same measurements. You get the exact same measurements. And on our previous questions, we talked about if that scale factor is greater than 100%, we get this, we'll say you get an enlargement. And if our scale factor is less than 100%, you get a reduction. All right, so using the dimensions you calculated on parts B and C, draw the complete snowman, and that would be the head and the bottom. So when you draw this and you get your complete image, it should look similar to this.